Hello friends, welcome to the very first video on engineering drawing part 1. In this video we are going to see what is the need of an engineering drawing. So in this video you can see the picture of the various components ranging from the safety pin, which is a smaller one, to the house larger one. In fact, in our day-to-day life we come across a lot of components which may be the smaller than the safety pin and larger than the house. So size of the component doesn't matter here, because whenever you want to manufacture the component you must know the size of that component which you want to manufacture. Not only the size, as well as the material. Not many things are there in engineering. When you want to manufacture the component, you must know the specification of that component. So out of those specification, the dimension and the material are the basic one. Many more are there, but we will not go into that detail right now. So when you want to manufacture the component, then you must know the size and the material of that component which you want to manufacture. So how one can tell this specification to the manufacturer? So if you are thinking that telling about the size and the material specification of component orally to the manufacturer, then this is going to be very difficult if it comes to a large size component or a complex component. It may be possible for a small size or a simple component that you are telling about the size and the material of that component orally, and the manufacturer is able to manufacture it. But if it comes to the huge or the complex component, then giving this information regarding the size and the material orally is not possible at all. So we take the help of a drawing. So we prepare a drawing of that particular component, and we specify some details of that component on that paper itself, and it becomes an engineering drawing. One question might have arisen in your mind, that what is the difference between the drawing and engineering drawing? So if you do a Google to find out the meaning of drawing, then you will find the meaning of a drawing is, it is a picture or a diagram made with pencil or a pen. So it's kind of a very simple drawing, as you can see here. Here we have the drawings of chair, which shows you the shape of the chair, not the exact size of the chair, not the material that chair is having. So it is just a drawing, it is just a drawing prepared with the help of pen or pencil, which doesn't show you the details of that particular chair. Similarly, if you search for a definition of a technical drawing, then you are going to find that it is a precise and detailed drawing of an object as employed in engineering. It is very precise and detailed drawing. Precise as far as the dimensions are concerned, and details means all the specification, material, whether it is required any further processing or not, whatever. As I told you, a lot of things are specified in technical or engineering drawing. We will not go into that detail for now. You just keep in mind that the dimension, the material, these are the two major one which we must specify in any engineering or technical drawing. So engineering drawing and the technical drawing, they are almost same. You can see here, an engineering drawing is a type of technical drawing that is used to convey information about an object few more lines are there. If you want to read it, you can pause the video and just go ahead. I will not read it over here. So let's move on to the next thing. So here you see, this is also the search result of an engineering drawing of chair. So here you can see the number of drawings are available. So most of the drawing shows you the three views. Here you can see 1 2 3, here also 1 2 3, 1 2 3. So different views are shown in this engineering drawing, and not only the views but also a lot of informations are provided in that. Let's see it. So here you see, this is one of the engineering drawing or technical drawing of a particular chair. So what details are shown here, let's look at them. So leather, the material is shown. Wood, the material of the legs, that is the frame of that chair is made up of wood, and the cushions or the materials rather than the frame is the leather. Not only the material, but here you can see the 567, then 530, this 30, 465. All these are the dimensions provided, and in order to get all the details of this chair, we have to show all these dimensions in different views, because it is not possible to show all the dimension of that chair in single view. So we'll come to this in later few couple of minutes. So this is what basically an engineering drawing is, which is a drawing which gives you the specification of that particular component, like the dimensions, the material, etc. So you again, one question comes in mind, that if you want to prepare a engineering drawing, then how many views are required to know all the dimensions from the drawing? How many views are required? So that's the question. So let's see one example. This is the front view of one particular object, and this one is a side view of the same object. The front view of that object looks like a rectangle, here you can see, and side view is also looks like a rectangle. In front view you see a rectangle is of a size 100 by 25, and in side view you see a rectangle of a size 50 by 25. So can you imagine which component it is whose front view and side view are shown in this picture? Pause the video and think about it. I hope you got it. So it's a simple slab which has the dimensions: length is 100, width is 50, height is 25. So think about this scenario in which, if you have these two views with you, that is front view and the top view, side view, are you able to manufacture the component exactly looking like this, or you may have some other component in your mind whose front view and the side view are same, means like this. So if you observe carefully, if you look at this object from this side, then it will look like this, that is a rectangle of a size 100 by 25. So height is not mentioned here, but let's consider it as a 25. The height is 25. You can see the radius here is 20, so here radius is 20, so 20 plus 20 would be 40, plus this 10, so total width is 50, which is shown here as well. So this is 20, this is also 20, and in between these two center point the distance is 60. So 20 plus 60 plus 20, total length is 100. So if you look at this object from this side, then it will look like this. Similarly, if you will see this object from this side, then it will look like this. So the main thing over here to show is, if you have the front view and the side view only, then it's very difficult to identify the actual 3D object, how it will look like, or whose front view and side view are this. So this leads to a confusion. So what's the solution? So let's see. If you want to give an information regarding this object, then we can draw the front view, which is a rectangle, which will appear when you look at this object from this side, and you can draw a top view, which is the view when you will see this object from the top side. So when you look at this object from a top view, it will look like a rectangle of a size 50 by 100, which is shown here. If you look at this object from this side, then it will look like a rectangle once again, which is of a size 25 by 100, which is shown here. Right. So if you, instead of giving the front view and the side view, if you provide front view and the top view, then it's quite easy for the drawing reader to imagine whose front view and the top view of whose front view and top view are this, right? So if you have this object, then definitely in front view you are going to see a rectangle of a size 25 by 100, that is from this side you will see the object, then you are going to see a rectangle which is here. And if you see the same object from a top view, the top view now will look like this. So this front view and the top view of this object is different than this front view and top view of this another object. So now confusion is not there. We can easily see that the top view of both the objects are now different. So we can somehow imagine that this front view and top view are of this kind of object who is having the curvature at its four corners. What does it mean? Does this drawing front view and top view gives all information of dimensions of any object? Means only drawing front view and top view is enough for showing the details of any object? Let's see. Look at this object now. This object's overall dimensions are, the length is 100, width is 50, height is 25. It has the surfaces. We will focus on to this main surface A, surface B, surface C. So if you draw the front view and the top view of this object, then in this front view we can see the surface A as a rectangle. Surface B also has a rectangle. In top view we are going to see the surface A, which is shown here, and surface C will appear as a rectangle, which is shown here. So what do you think? Just by knowing these two views, can we manufacture the component like this, which is shown in 3D? Pause the video and think on it. So here you cannot see the inclination of the surface A. You don't know that this surface A is inclined. You cannot see it in front view, not even in top view. What does it mean? In front view and top view, information regarding that object is not fulfilled. So we must need to draw one more view, and that is the side view, where you can see the surface A, which is having an inclination, which is here, which you can see here. So drawing only two views, which we saw in previous case, is not enough in this case. So it leads to one conclusion, and it is minimum or maximum 3 views are necessary to draw for showing all the details and or dimensions of any object. 3 views are necessary. So this is what the conclusion of this video. I hope you understood the thing regarding the need of engineering drawing and how many views we need to draw in order to give the details of that particular component. So that's all for today. I am Manoj Sonone signing off till we meet next time. Thank you.